Ad Astra is our mantra. Ad Astra to the stars. Ad Astra, it's who we are.
Welcome to Around Space. I'm Kent Miller. Today we're going to be talking about the state of manned space policy. I'm delighted to have with us Mr. Tom Hill. In 1990, he got his bachelor's in aerospace engineering from Penn State. Thereafter, he joined the Air Force and served our country as an airman for 25 years. He's also a member of the Mars Society. Also with us today, Dr. Robert E. Terry. In 1978, he got his PhD in physics from Johns Hopkins University. 1980, he joined the Naval Research Laboratory. 1999, he was one of the founding members of the Mars Society. Welcome back to this table.
Thank you. Good to be here.
All right, so tell us, where do we stand in terms of manned space policy?
Well, I think the best description would be confused. NASA is currently building a large rocket, which is the law of the land, that NASA will build a large rocket. It's called the Space Launch System. It's been given other nicknames as well, but we'll stick with Space Launch System here. It's using old shuttle parts, including the engines that used to push the orbiters into space. It's got the potential of lifting quite a bit of cargo into space. Its first flight is scheduled for the year 2017, and its second flight is scheduled for the year 2021, which, if you look at the math there, it's not very frequent flyer.
Yes,
It's got some issues there. They're also required to build a capsule to sit on top of that craft, and the capsule is actually going to fly for the first time this year, not on the mandated system, but on another system that's already flying. So there's plenty of questions there of why couldn't that happen normally. In the meantime, a small amount of the money that's being spent on those systems is being shunted off to the side to deliver cargo to the International Space Station, with an idea of moving forward from there to eventually making a crewed capability, be able to launch people to the International Space Station.
Now, this is money that's going to the private sector, really.
Correct. In a different model, the Space Launch System is being built by the private sector as well, but it's a different model where NASA's much more involved in the design. Even Congress is involved in the design as it stands. But the crewed system, the commercial system, it's literally NASA puts together a list of things to say, we want you to do this, this, and this. And when they've met each of those steps, there's a payment, a milestone payment for each one. Yeah. For instance, as we're talking now, there's a capsule docked with the International Space Station that was delivered by a crewed, a commercial capsule. And it's there, it's about to return to Earth.
So. All right, very good. Now, why are we doing manned space anyway? What's...
It's kind of a long story. It started pretty much as the space race in the 60s, and it's possible, in fact it looks like it's purely momentum from that carried us forward. There was the Mercury program, the Gemini program, the Apollo program to land on the moon. That was to meet the challenge it was soft power during the Cold War to say, we can land somebody on the moon, we could probably put a nuclear weapon on your doorstep if we wanted to. And that carried us through the 60s into the 70s. So then there was a follow-on. Well, what are we going to do next? So they built the space shuttle as something that would make space routine. It didn't make space routine. It actually made it more expensive than it had been before. Yeah. And the space shuttle carried on. It flew for over 30 years and then shut down with the idea that it would be replaced by something else. The money that was being used to fly the space shuttle would be channeled towards accelerating its replacement. But it boils down to, once that impetus, the space race faded away, people started looking around and say, well, why are we doing this?
Right.
The first answer was international cooperation. the space station, International Space Station right now, the idea was we'd keep some Russian scientists and engineers busy so that they wouldn't be doing other things that we don't want them to do. But that hasn't held together as well as some people had hoped. So now the question is, well, why are we sending people into space? And it's science. There's still the old idea of national prestige and things along those lines, but that boils down to it's cool. It's cool to send people into space. And how much money are you willing to spend on cool things that aren't a national priority?
Right. All right. Well, NASA is kind of a strange organization. It has operational activities such as launching rockets, but it also has some research and development activities. It does science as well. Many pieces of NASA are actually former military bases, so there's that angle as well. So where's NASA going here?
Well, that's kind of the big question. Their planetary science is doing fairly well right now. There's a lot of spacecraft returning data from Saturn and Mars, and there's a spacecraft orbiting Mercury. One of the issues going on, though, is there's not many spacecraft being designed and built right now in that critical timeline where they're actually bending hardware. There's lots of concepts being thrown around. And so that's one area that's got to focus. But I think this all comes back to the way NASA was formed in the late 50s in answer to the whole space race. That was a consolidated civilian effort, and they pulled these disparate parts, including military bases, including research facilities, and they pulled them all together into this new organization. And it's kind of spelled how NASA works today. The headquarters of NASA in Washington is a somewhat limited power because it has these individual organizations that were used to being on their own for a long time. And they also know their congressmen's They've got their congressman on speed dial, so if something doesn't go their way, they can call them up.
Yeah, I'm familiar. There's a tension. Yeah.
Well, recently at a Humans to Mars summit, NASA laid out an entire program of how they plan to go to Mars, albeit slowly compared to other folks, but they do have a well-defined program, albeit heavy on technology as opposed to schedule. There's still the same notion of caring for constituencies as much as you care about mission and getting things done, but it is there, and they're trying to right now find sort of the middle distraction, because they're not ready to go to Mars yet, or at least not ready to admit they're going to go to Mars and can do it. So first the middle distraction was going to be the asteroid mission. And now that's kind of getting supplanted by Tito's flyby. NASA is almost toying with co-opting the Tito flyby to their own mission, they call it. And that, they say, they were very pleased that people running the Tito mission decided they couldn't actually use the SpaceX rockets that were going to be on stream. They had to have something as big as SLS. So now that pushed the time frame off for the Tito mission to kind of be in tempo with SLS, but at least now SLS and Orion have that mission, and they're focused on looking at that. So that little piece of the intermediate game is kind of where some of the budget focus is working right now, at least in the interim. Now, whether or not that survives the process, who can say? But there's a lot of good information out on the web from this Humans to Mars summit. Explore Mars sponsored it, and it's an easy Google. There's plenty of stuff to find and read, but that's kind of the intermediate game, and no one knows how that game is supposed to play out. Do you really get an asteroid, or do you flyby of Mars? Those are good precursor missions for Mars. The flyby of Mars is always in some of the original thinking of Bob Zubrin and others at Mars Society. The flyby of Mars is a safety valve. You do a drop down, a free return to Venus, and come back to Earth, which is exactly Tito's scenario. That safety valve, it sort of tells you want to go in about 6-7 months. If you go too soon, it's not there, and if you take too long, it's not there. So that kind of tells you the kind of window. So practicing that is a useful precursor. The other possibility is actually, it might be as useful as an asteroid mission. a lot of trade space going on, a lot of PowerPoint engineering.
Yes.
And that's unfortunately where it does stay, although they
Well, let me ask also a different, maybe more of a long-range question, is that we've seen over the decades that sometimes if a technology is matured at NASA, somehow the technology gets transferred to industry and the operational aspects also get transferred. I'm thinking from the early days, we had the example of the communication satellites.
Yes, and these are all wins. This is the communication satellite technology, weather satellites, some of the military applications, the global positioning system satellites that are now part of everyday life for people, down to from jogging watches to your what's in your car. These are all wins. But if you look at it from NASA's point of view, once you develop something that's cool that works, it's taken away from you. From a bureaucracy point of view, it's a net gain for the system, but for that bureaucracy that used to work in that, it's a loss.
Well, since designing and operating rockets is such a large portion of NASA's budget, what happens when that gets taken away?
That's always going to be a factor, and there's a large group of people at Marshall Space Flight Center that whenever there's any rumblings that NASA's not going to design rockets anymore, we were talking about them having their congressman on speed dial, that's what happens. They call their congressman. But looking for that role, that would be the wise thing to do. What can we do next? And with some of the motion that's going on now with deliveries to the International Space Station being done by commercial entities, there are commercial entities as well, that are talking about lofting people into space, businesses, tourists, things along those lines. So you could look at where now we're starting to think about space as a transit system, a transit medium, not an end to itself, but something that you travel through.
Yeah.
And in other transit systems, the water, the air, things like that, what role does the government play? And the government in those roles plays the role of regulation, safety, protecting human life. And that is probably a way that people should start thinking.
Well, the transportation sector we have the road systems, we have the airways, we have the seaways. We could even include pipeline and rail traffic.
Right.
Now, all of these sectors do get regulated to some degree under the Department of Transportation. Now, so it sounds like what you're saying, that at some point, space transportation gets taken away from NASA, becomes, well, at least the regulation thereof becomes part of the Department of Transportation.
Right, that's already starting in some ways. The licensure of flights into space is taken through the FAA. That portion of it has already happened. But NASA doesn't fall under that because they're a government agency. So it has started to move that direction. Any commercial flight will have to get a license from the FAA.
So just as FAA does not have its own airlines to ferry its civil servants, so eventually NASA will no longer have a space line to ferry its civil servants.
Correct. That's the model that we're moving towards, except with the exception of this Space Launch System and the Orion capsule, which unfortunately on the scale of budget, if you were to look at the budget of what's being spent on these, it's on the order of $3 billion a year to develop these two systems, compared to the couple $100 million a year going towards the commercial crew effort. So, and once again, this is all mandated by law. NASA's doing this because they're being told to by Congress, but that's where their focus is, and it's questionable whether that's where the future is.
Well, what if the SLS is a dinosaur? What happens if, let's say, the new commercial providers, and you've given, I think, two examples, Orbital is possibly one, and SpaceX is possibly the other.
There are some others as well, Boeing and Space Dev. They're doing some developments of their own, but the two that are flying now are Orbital and SpaceX.
What happens if SLS really at some point loses its reason for existing?
I think that possibly some pieces of it could be morphed over to be mated with the other vehicles. possibly the Orion capsule could find itself boosted by other vehicles. And so a lot of that development for the capsule would not go wasted. A lot of the concepts might change. They might rescale it. They might just take it and cookie cutter it over to another vehicle. But they say, look, this has been proven to a degree. And it was asserted that in the not too distant future, NASA would be making entry, descent, and landing tests with things like the Orion capsule in the upper atmosphere of the Earth. Because you stagnate at 100,000 feet, that's mechanically equivalent to landing on Mars. So they're going to actually have planned systems, hypersonic decelerators, and all kinds of stratagems to understand how to take this fairly fat, bulky Orion capsule and land it on Mars. So that's in the pipeline. Those concepts and developments are there. Experiments are being planned. So I don't think all of it would just up and look like something that was a total dead end. I don't think that's going to happen. The probabilities are that there may be some missions for SLS that it and only it can finally do, such as the Tito flyby as conceived. Tito-style flyby, NASA, I guess would call it, because it's theirs now too.
Tito-esque.
Well, better than Putin-esque, I suppose.
Yeah, that's true.
In any case, and Putin's a whole other card.
That's a whole other discussion.
That's a whole other discussion. This ping pong back and forth about whether or not is that going to motivate us to finally get ready and change the way we think about rating human systems? Are we finally going to say this self-inflicted wound due to the shuttle stoppage, we had enough is enough, and yeah, maybe the SLS goes a little bit, but you still have to go ahead and say, let's let the private system really go for human rating and get out from under this problem. That could be remotivated rather quickly if things go south in Georgia, the other Georgia.
If something is
Suppose our
declared
Georgia.
important, things can get done quickly.
Right.
That is an axiom.
Well, let's sort of maybe in broad brush, tell me what are the main differences between the commercial approach and, let's say, the government approach? Now, I've had a curious experience a few years back listening to a congressman expound about the NASA center in his district. And he didn't know what they were doing, but he did know that 2,000 jobs in his district was the right thing for America. So I know there's considerations that maybe the private sector doesn't have, but beyond that, what else?
Yeah, definitely the commercial sector. It's brought in as if you're in favor of commercial things, you're saying that the idea that they're out to make a profit is a good thing. If you're against commercial activities, the fact that they're out to make a profit is a bad thing. So everything has two sides. The elephant by the blind man. But some of the commercial efforts that are underway right now, for instance, Orbital Sciences, their rocket was pulled together with existing parts. They're using Russian engines. Their capsule is built in Europe. So there wasn't a lot of research and development involved in building that rocket. They were there to fill a need for 8 flights to the International Space Station. So they built what was needed to do that and went about it. Whereas the government approach is going to be, there's more of the, we want to build it, and we've got a congressman who's going to say that we can build it. There's going to be more of that kind of thing. There's definitely some interest in, we've been working on this technology for 10 years. We should include that in this new project. That's going to be tacked on. Whether it's directly necessary or not, that may not be a factor. Whether it's actually necessary, we're going to include it. That's a player as well. And then the different constituencies that have to come together to agree on something before something happens is just, the number of them in a government situation is usually higher than it would be in a commercial thing. And now the SpaceX experience, Elon Musk, the founder of SpaceX, he's got a stated goal of getting people to Mars, but we've got to make money in the meantime to do that. And the efforts that they're doing now in research and development and engineering, flight engineering, with their first stages and the idea of returning stages to the launch site. The the old guard said that, well, we tried that and it didn't work. Well, I'd never actually seen anybody try that before, but you know, we know it didn't work because it hasn't been done.
Yeah,
yet.
their version on PowerPoint didn't work.
Right.
Yeah.
But the version that's out there floating around in the test bed and coming back down to Earth from the last orbital strike, that's working. And
Yep.
so SpaceX is in this position where it's kind of in between government and in between a purely profit enterprise, because SpaceX is backed up by a boatload of money.
Right.
And so they have that aspect of being somewhat endowed, and they can take a longer term view. The biggest problem I see in exploitation and moving ourselves into space is to understand that we need long-term thinking and long-term money in order to attack this enterprise. And one of the big discussions, people are in Congress now, people are finally saying, look, you've got this budget that kind of takes you to Mars in 2030 or whatever. This is a minimalist budget. You can't do anything credible and useful on anything less. And if you were smart, you'd do a lot more and bring the money up. I mean, the fact of the matter is that we've degraded our spending on the physical sciences for 40 years in terms of real dollars. And you can't make new and different things degrading the true value of what you spend. We could triple or quintuple the money we spend on physical sciences and exploration and never see it in the budget deficit, never see it in the debt. It's that small. People don't understand that NASA operates on a fraction of a percent of the federal budget.
Right.
And if you really want to do something that's useful to you, you're just going to have to back away from this hard-headed, almost a Luddite attitude that you have to spend just no more than you can, the minimal amount to do stuff in space. That's not the way to get things done safely and effectively.
All right. Well, I think one of the, because I've had it, both the government and the commercial experience, is that in government you tend to define missions and then, you know, marshal resources to try to
Right.
achieve those missions.
Right.
Whereas in commerce, it's more about serving markets.
Right.
It's a different mindset, and this also leads to more attention to what your expenses are
Right.
in trying to serve those markets.
Yeah, you have to stay in business in the commercial
Right.
area. Government is always going to be in business, according to them.
Well, they
So.
have a good track record
do.
of doing
They
just
do.
that.
Constitutionally mandated track record, I should say.
as long as you defend the realm.
Indeed. But the thing is that the contrast with government and private enterprise here too is that government is structured to be inefficient. And they're structured to be inefficient for a reason. We structure them that way so that we can keep track of them, so that there are various places always looking over each other's shoulders, and a lot of redundancy, and that costs money. And that ability to prevent people from just running off with the budget and going to Maui or going to Central America and setting up a colony or just spending it, that constraint to follow the people's money leads to a lot of excess spending.
Yeah.
And there's no way around it. I mean, and in a private enterprise, you would just probably be very draconian, even if you suspect such things, and hope that is enough to just scare people from not doing it. Plus, you have, as I say, a much more linear way of deciding what your expenses are and what your missions are. So you have that trade-off. But then again, if you had a long-term endowment doing this kind of stuff, you'd have the similar problems with the government in the sense that the endowment would have to keep track of its capabilities and how it's spending money too. And it wouldn't be quite as linear and narrowly focused as a private enterprise. There's a trade space however you do it, but longer term thinking, I think, is going to indicate that you are always going to want to put up with some of that inefficiency in order to gain trust in the system and maybe to gain safety.
Well, as the space transportation moves away from the mission model and more towards the markets model,
Right.
What's left for NASA? I mean, what are the missions? You know,
The
Well, I
really,
think-
really crazy stuff is left.
all right.
They
let's
have
hear
a
it.
whole.
Let's
They
hear
have,
it.
well, they have people working on electric rockets now that require fusion to operate. All right, fusion is actually on their chart a date certain when nuclear fusion will come on stream as an engineering possibility for
It's on a
transportation.
PowerPoint chart.
It's on a chart.
Right.
You can download it. It's right
They don't
there.
even have it working on the ground.
But moving
You're
a
right,
little,
but it's there on their
Okay.
planning chart, along with solid metallic hydrogen and a few other odds and ends. So they can get in the antimatter drives, and they can get on the really crazy stuff, and
right.
keep them out of trouble for hundreds of years.
now moving a
pretty
little
interesting.
away from NASA, thinking about the government in large,
yeah.
once you move into a market approach, what role does government normally play in human activity? And it's safety, regulation, security, protecting the public, and protecting those who are involved in that activity. That's another area in government activity in space that I don't think has been investigated that much.
That's it.
Well, if you go back to the Federalist Papers, I guess the main areas discussed there where it would have been defense, of
Yes.
course, commerce. Having a unified country gives us better commercial terms, right? And then, of course, finance.
Right.
And, but
And here we're talking along the ideas of defense of the planet, planetary defense.
all right,
That's one of the aspects.
okay, that's worth a whole show in itself, I think.
I think so. I think so. I think we may have even talked about it at one point.
Okay. Yeah. Dr. Terry, you fly an airplane, don't you?
No.
No.
Although I'm recently corrected my vision, so I'm hoping to fly gliders with Civil Air Patrol.
Oh,
All
excellent.
right.
I function with Civil Air Patrol as Director of Aerospace Education,
Okay.
and so that's pretty much a non-flying slot.
Oh,
but
you're-
I'm not going to leave it that way forever. In any case, no, I would love to, but I am not a pilot, but I do operate with Civil Air Patrol in aerospace education.
Okay, sounds good. All right, I think we're out of time, so thank you so much. for
Thank
being
you.
so-
Always a hoot.
And thank you very much for joining us here at Around Space. Mr. Tom Hill and Dr. Robert E. Terry talking about the state of manned space policy. Thanks for joining us, and see you next time.